The most essential thing to learn from this video is that energy is never created or destroyed. It's only ever transferred between different forms and objects. This principle underlies loads of the physics course. But today, we're just going to look at the different forms that energy can take, how energy moves between them, and what we mean by the term work done. Whenever energy is transferred to an object, the energy is stored in one of that object's energy stores. We take a look at each of them in other videos, but to give you a basic idea, there's thermal or internal energy, which is basically the heat energy trapped within an object and is related to the temperature of that object. Kinetic energy, which is associated with the movement or motion of an object. Gravitational potential energy, which is the energy that an object possesses because of its position in a gravitational field. Elastic potential energy, such as the energy held in an already stretched spring. Chemical energy, which is held in chemical bonds. Magnetic energy, which is what holds magnets to your fridge. Electrostatic energy, which is what occasionally gives you a shock when you touch your car. And finally, nuclear energy, which is what we get from breaking atoms apart. Now, the key idea is that the energy in each of these stores isn't fixed. Instead, it can be transferred from one to another. This could be done mechanically, such as physically stretching an elastic band, electrically, such as plugging something into a socket, by heating, or by radiation, like light or sound waves. When we consider a particular object, or group of objects, we can call the collection of matter a system, which is just the fancy term that you need to use in physics. When the system changes, energy is transferred, either between objects or between different forms. In an open system, the matter of the system can exchange energy with the so-called outside world, which is just all of the matter that's outside of our system. This means that an open system can lose or gain energy as it interacts with the outside world. By comparison, a closed system is separate from the outside world. So neither matter nor energy can enter or leave. And so even though energy can be transferred within the system, the overall change is always zero. To understand how this actually works in practice, let's take a look at a couple of examples. Imagine we have a kettle and we fill it with water. When we turn it on, electrical energy from the plug socket flows to the heating element of the kettle, where it's transferred electrically to the thermal energy store of the kettle's heating element, which basically means that the flow of electricity warms the metal heating element. The heating element then in turn transfers the energy over to the water's thermal energy store, and after a short while we have a boiled kettle. Another way of saying energy transferred is work done, and there are two main types you need to know: mechanical and electrical. Mechanical work done involves using a force to move an object, such as kicking a ball up in the air, which involves energy from the chemical energy store of your leg being transferred to the kinetic energy store of the ball. Electrical work, on the other hand, is done when current flows. You can think of this as the energy required to overcome the resistance in the wires of a circuit. To put this into practice, imagine a train that's about to cross a broken bridge. In order to stop, it applies the brakes, which creates friction between the brakes and the wheels. We say that the friction does work as it slows the train down, because it causes energy in the wheel's kinetic energy stores to be transferred to the thermal energy stores of the surroundings in the form of heat, which will